Well, hello everyone. I hope everyone's had a great experience at PASS Summit 2022 or 2021. That is. Session is titled "SQL Server and Intel Unlock Better SQL Performance and Scalability." This is specifically focused on persistent memory, PMEM use cases, and where SQL Server 2022 can take advantage of persistent memory and better processing. We'll also cover SQL Server backup compression capabilities with Intel QuickAssist, backup compression in order to get faster backups and with better capacity even when your servers are under load. And finally, we're going to cover some SQL Server 2022 features that may be improved through better processing. My name is David Pless, and we are Tigers that say War Eagle. My previous role at Microsoft, I was a premier field engineer for over a decade. I was an MCS consultant as a partner consultant before joining Microsoft. The past 2 years, I've been a senior SQL program manager focusing on SQL Server and Azure Virtual Machines performance topics, and now the relational storage engine. Now, we have limited time, so I think it's about an hour for this session. I'm just going to jump in. We'll have references at the end where you can explore further. I'll also be available in the Q&A along with other colleagues, and of course, you can reach me on email or Twitter, which is usually the best way to get a hold of me. One more thing, put any Q&A in the chat. We'll do our best to answer any questions you may have, and hopefully you should have some time at the end to bring in the team to discuss more. And now let's meet our other presenter from Intel. Darren, take it away.
Yeah, Darren Frymath, been at Intel for about 26 years. I'm currently a senior solutions architect focusing on databases, one of them SQL Server, and Intel products and features. To the right there is a bunch of stuff that any one of those images I could tell a story about that kind of describes me, but I just wanted to splash up some details, but that's good for now.
Another soccer family, that's great. All right. So let's, reflect on your current infrastructure. When you think about your environment as it is today, you probably have, strong investment in hardware, storage, separate servers for separate systems, all tiered platforms. And some of these platforms may be running different apps, SQL 2012, maybe different flavors of Windows Server from 2012 to 2016. And of course, the biggest investment is usually the SAN. And while this is a good investment, there's many customers that are finding that through this initial investment, it doesn't meet demands coming from like analytics and big data outcomes and machine learning. And all the while, our data volumes continue to explode. And so there's much more data at rest than ever before, with only a small amount of the ingested data ever really being processed. And we continue to produce data at record levels, and the systems can often barely keep up to meet those demands. So in this session, we're going to cover the benefits of using SQL Server 2022 on Intel Optane Persistent Memory and how SQL Server can build upon these technologies. And then next, we'll cover the capabilities of Intel QuickAssist technology that can help improve backup performance and capacity. And finally, we'll cover the new storage engine features in SQL Server 2022. Okay, so your data has always been in memory. In the database engine, the assumption is that data resides on disk, and we use memory to make data access faster, but the primary data residence is on disk. So the storage engine is designed with this premise in mind. Data is divided into pages, which provides an efficient method to transfer data from disk into memory. The buffer pool mimics the page structure to make it easier to transfer data from disk into memory. And whenever we access data, it's from memory. We can't read a page of data without first putting it into the buffer pool. And as long as we keep pages in the buffer pool, we do it as long as we can, so that subsequent access is faster. Now, since the beginning of SQL Server, the world of data storage has been divided into two tiers. We have our fast, volatile memory, and then maybe slower, more stable storage. But this story is really rapidly changing. Disks are getting faster, memory is becoming non-volatile, and in short, the lines are kind of blurring. And what we call disk or memory is really irrelevant. It's all storage. And the storage has different characteristics such as speed, capacity, latency. It can all be used to store data either temporarily or permanently. So in a world where memory and disk are really kind of converging, our SQL Server database engine needs to be able to take advantage of what these evolving technologies has to offer. And so with this, we are going to talk about what is persistent memory, or PMEM for short. Why is it important? What are the trends with data volumes? And we'll get a good idea of how persistent memory works. And Darren from Intel is going to tell us about the hardware options and the modern capabilities that really trying to drive these data scale workloads, large scale data workloads. Okay. So as you can see from the slide, we have hot data that is more frequently accessed as opposed to cooler data. SQL Server copies data from physical disk, so cooler data, into memory, warm, hotter data. And accessing that memory is typically faster than accessing disk storage. As said, a page read will copy data from disk into the buffer pool. Some of you may have seen this pyramid before, but you see we have the buffer pool that maps to the very fast memory. SQL Server needs quick access, so the more frequently accessed pages in memory, the better. And of course, SQL data that is less frequently accessed remains available on disk storage. We will need to select this data at some point and bring it into memory. So we also need our disk storage to be efficient. And remember, the ongoing trend is that we're going to continue to analyze more and more data that is currently at rest. Now, the performance differences we see between the hardware options are evident. We have various tiers of storage, from traditional spinning disks, which are slower but cheaper, to the next tier of SSDs. We can have a mix of traditional hard disk, disk-attached SSD, PCIe, NVMe, and the storage tier is going from milliseconds to microseconds to nanoseconds, compared to the upper tier of like 80 nanoseconds, which is typically what DRAM provides. Now, here is the gap, and here's our opportunity to fill. The gap outlines between less than 100 microseconds with SSDs versus less than 100 nanoseconds with volatile DRAM. So Intel has two core options that reduce latency while maintaining a very high level of persistence. And these technologies is the Intel Optane SSD, and the other is Intel Optane Persistent Memory. So I focus on these two technologies, really how they can be used to improve SQL Server performance. We're taking like a layered approach, starting with the hardware capabilities, operating systems, API that can leverage the hardware, and then finally how SQL Server can take advantage of these technologies. So after Darren kind of breaks down the hardware options and discusses that further, we'll talk about how this aligns to SQL Server capabilities. Sound good? All right, Darren. So tell us a little bit more about this.
Okay, so as Dave pointed out, there's this space between traditional hard drives and DRAM that's being filled by multiple storage options. So I'd like to talk about some of the products that Intel is innovating in this storage space that you can use on your database platforms. You know, so first at the top of the, whoops, blue quick there. So first at the top of the pyramid is Intel Optane Persistent Memory, also called PMEM for short. PMEM is enabled in systems with third generation Intel scalable processors, and it operates on the DRAM bus. And as shown here in this picture, they're packaged in a DIMM package, and they look like traditional DRAM, but they're very different. They can be used as volatile or persistent memory and added to systems in place of DDR memory. And their sizes range from 120 gigabytes to 512 gigabytes, the largest DIMM packages available. I'll talk a little bit more about PMEM in the next slide. So I wanted to move down the pyramid. Next, Intel Optane SSD P5800X provides the fastest performance needed for the most data-intensive workloads. With a combination of low latency, fast throughput, and high endurance, they're ideal for fast caching and tiering of hot data. Average read response times remain low, remain below 6 microseconds while maintaining a 730 mixed read-write bandwidth of greater than 8 gigabytes per second. So these drives are incredibly fast, and they can reach up to 1.6 million IOPS of random read or random write data performance. So these are a great solution for your database performance. So one of the great benefits of Intel Optane, and you're a little quick there, Dave.
Sorry.
one One of the great benefits of Intel Optane Media is that it allows for a much larger number of lifetime write cycles than like a normal SSD. At 60 disk writes per day, it has a greater than 10 times the endurance of many NAND SSDs. So Optane devices, these Optane devices connect via PCI 4 on a U.2 connector, and they come in sizes from 400 gigabytes to 1.6 terabytes. And they easily fit in that middle space, middle storage space. And so lastly, at the bottom of the slide here, is the Intel SSD D5 P5316. It's specifically read optimized for both enterprise and cloud workloads to deliver better latency, expanded management capabilities, and NVMe features. So it's best suited for mostly read workloads as well as large block writes. So this is where the majority of your data would be stored. It offers a mixed bandwidth of up to 7 gigabytes per second and a 4K reads up to 800,000 IOPS. Its endurance is not as great as Optane. The endurance is about 0.41 disk writes per day. And it's not as performant as Optane SD, but comes in much larger sizes from 15 to 30 terabytes. It also connects via PCI 4. And if using the 30 terabyte size, in like the E1 form factor, you could potentially align these across your system in front of your chassis, providing up to 1 petabyte of storage in just 1 U of rack space. So that allows for some very large databases in a pretty small space. It's a bit advanced. So next, I'd like to talk about, go back and talk about more about PMEM. But before I talk about PMEM, so what is Optane? So Intel Optane is a media that's unique. It's a unique memory technology with a number of important advantages over top of other memory options. Intel Optane enables write-in-place memory updates, which avoids extra updates. It's byte addressable like DRAM, but it's non-volatile like NAND, and has a read-write latency between the two. But most importantly, as I mentioned earlier, it was created with new materials, purpose designed with high endurance in mind. This endurance advantage means that Intel Optane has sufficient endurance to act as system memory. So Intel Optane Persistent Memory 200 series puts Intel Optane on a DDR form factor, putting it on the DRAM bus. So this used in conjunction with a third generation Intel Xeon scalable processor fills the gap in capacity, persistence, and security produced by DRAM. So what are the DRAM capacity, persistence, and security gaps I mentioned? First, PMM allows you to have a much larger storage capacities at a much lower cost than DRAM. When using the 512 gigabyte PMM modules, you can have up to 4 terabytes of PMM and 2 terabytes of DRAM per socket on a 2-socket Xeon system. So on a 2-socket system, this is 12 terabytes of addressable storage. This enables larger database capacities or VM densities, enabling you to consolidate and reduce your server footprints. PMM also allows you to persist data in byte addressable memory. This provides much faster access to your persisted data. The persistence ensures that your data and log writes will not be lost in case of unforeseen system interruptions. Lastly, all data in PMM is encrypted by application transparent AES 256 encryption. This enhances the security of the data without requiring any code changes. So in places where you need large capacities of secure persisted data, Intel Optane allows you to securely and affordably boost your memory capacity per socket, and you should consider the Optane persistent memory.
All right. So let's thank you. So let's cover the SQL Server 2022 overview. We're going to look into memory optimized topics. We'll look at kind of like the in-memory feature family. You know, SQL Server as we know it can be a very IO intensive platform scaling to your application's needs. When we think about the IO in SQL Server, what do we do with IO? You know, we read pages, we write pages, we do transaction log IO as blocks. With all that in mind, though, you kind of have to ask yourself, how do we take advantage of persistent memory? How can we use SQL Server 2022 and use this technology as a drive? And what other ways can SQL Server leverage persistent memory in other modes? And so that's really what we're going to talk about here. Now, first, like I kind of said there, is let's talk about the in-memory feature family. Let's review it a little bit. And this is what we kind of, call this family of technologies, this in-memory feature family. And so the concept of an in-memory database system refers to a database system that has been designed to take advantage of larger memory capacities available on modern database systems. So an in-memory database may be relational or it could be non-relational in nature. It's often assumed that the performance advantages of an in-memory database system are mostly owing it to being faster to access data that is resident in memory rather than data resting on even the fastest available subsystems. However, many SQL Server workloads can fit their entire working set in available memory. So many in-memory database systems can persist data to disk and may not always be able to fit the entire data set into available memory. A fast, volatile cache that fronts a considerably slower but durable media has been predominant for relational database workloads. It necessitates a particular approach to workload management. So the opportunities presented by faster memory transfer rates, greater capacity, or even persistent memory enables the development of features that can spur new approaches to relational database workloads. So let's talk about how this can align to SQL Server and persistent memory. And there's some scenarios that we'll walk through. So really kind of like a quick overview of where we can take advantage of PMEM and where the opportunities lie. So first is PMEM as a block device. So in this scenario, think of PMEM as a storage tier, okay? SQL Server storage engine will treat PMEM just like any other drive storage. So why is this valuable? Well, with the purchase of larger persistent memory modules, we can place our data and our log files on technology that performs seeks with less than 1 microsecond on Intel Optane Persistent Memory and less than 10 microseconds for Intel Optane SSD. Plus, the situation will support any version of SQL Server 2014 and beyond. Next, we have the persisted log buffer with log cache. This is that tail of the log scenario. And this is introduced in SQL Server 2016 and should be noted that it was in-memory OLTP that drove this work. So if you use a hackathon-based application with OLTP in our testing, the bottleneck became the transaction log. And the reason why is when we were improving in-memory OLTP to see how fast we could get by removing locking and latches and spin locks, we noticed the next bottleneck was write log waits. So even with in-memory OLTP, we persisted into an in-memory OLTP table, and we have to write to the log, and that became the bottleneck. And so this is where persistent memory comes in. The transaction log has a buffer per database. We take log transactions and put them in log buffers in memory. And then based on policies for commit operations, checkpoints, lazy writes, and so forth, we write all this to disk. And there's a process where we say commit to SQL Server. We take whatever's in those buffers and write to disk. In the typical scenario, this has been for years, this would be some sort of a challenge, a traditional, traditional storage. If on persisted memory, we know that the log buffer is already persisted, then when we say commit, we don't have to perform any additional work to write to the log, and we don't have to worry about data loss. And this tail of the log technologies have been around since SQL Server 2016, SP1. Okay, so let's talk about the next one. So enlightened IO. So if you dig into persistent memory, a good portion of the optimization is avoiding kernel switches. Essentially, you can bypass the I/O stack in order to reduce the number of CPU instructions. Using what's called a direct access approach with the data in the log on persistent memory modules, SQL can treat all of this like it's cached in the buffer pool. And the beauty of all this, you don't have to do any specific configuration in SQL Server to enable this feature. You just put your data and log files on persistent memory storage, and when you start using SQL in this environment, we will be able to bypass the kernel and avoid the latency of traversing the I/O stack. And all we did is use persistent memory for storage. There wasn't any change, not even an alter SQL Server configuration change. All we'd have to do is put our database on storage, and we're suddenly faster. Now, previously, this feature was only available for Linux platforms with SQL Server 2019, but now on SQL Server 2022 and Windows Server 2022, we brought this enlightened I/O feature to SQL Server-based deployments. And one more, let's talk about hybrid buffer pool. So what if we could just take the persistent memory storage and just treat it like memory? We've already talked about how important memory is to SQL Server. So with this concept, if we could take our persistent memory and just use it for the buffer pool, it doesn't matter if it's in the DRAM or persistent memory, it just looks like buffer pool to SQL Server. And this is why we call it hybrid buffer pool. Now keep in mind that persistent memory modules will be slightly slower than DRAM, but it's definitely faster than storage, even NVMe. So to enable this, all we need is an alter server command in Windows or Linux, and it will enable the hybrid buffer pool after restart. As shown in the slide, there are no application changes. We don't want you to have to touch the application side. You just have to make maybe a configuration change, but you should not have to change your application to be able to take advantage of these features. All right. So now we're going to pivot, I guess, over to SQL Server backup compression. Darren?
Yeah, so yeah,
next thing
so the next thing to talk about is the backup compression. You know, in this section, we're going to talk about why you might care about hardware acceleration of SQL backups, and then we'll kind of move on to some details around QAT backup compression, followed by how QAT is integrated into SQL Server, and then maybe some quick performance numbers at the end.
Okay. Sounds good.
So why do we care about accelerating our backups? As the amount of data, you know, that being stored grows, the longer it takes for our backups to complete, and the size of the backup files are growing as well. It also seems that, you know, in today's world, our scheduling windows that we get to complete backups are also shrinking. So many have probably implemented solutions to help mitigate around these problems, like running backups on a secondary replica. However, even if you're running your backups on a secondary, there still could be competition for CPU cycles, depending on how your secondaries are used. Also, the backup files generated are still the same size. So ultimately, what we really want is to reduce the size of our backup storage, improve the speed of the database backups and database restores with as little impact on the workloads running on our SQL servers. So using built-in SQL compression can address the backup file size, but also using the built-in software compression steals compute resources from the main workloads we're trying to run, which are SQL queries. So in the amount of time that the backup takes can vary because it depends on how much CPU resources are available to perform the software compression. So what's a solution? This we can advance. The better solution is hardware acceleration. So hardware acceleration provides dedicated hardware to perform specific tasks. This dedicated hardware leaves the main CPUs free to do their tasks and is less likely to impact your SQL workloads. In this case, that hardware acceleration is compression. Hardware acceleration compression allows for SQL Server to have faster backups, faster restores, and have less impact on SQL workloads. It also reduces the sizes of backup files. So, good, Vince. So I'll talk about one of the technologies we have in the space. So there's Intel QuickAssist Technology, also known as QAT, is a technology that implements hardware acceleration and improves performance across applications and platforms. It includes hardware acceleration for symmetric and asymmetric encryption, authentication, digital signatures, and lossless data compression. It also significantly increases the performance and efficiency of standard platform solutions. So Intel QAT meets the needs that we discussed earlier for that hardware acceleration of compression needed for SQL Server. So in the future, Microsoft SQL Server 2022 will integrate the Intel QAT hardware compression technology to accelerate SQL backups on compute-intensive workloads on Intel platforms. So in performance testing with Intel QAT and Microsoft SQL Server has shown to have up to a 2.3 times speed up with database backups. Also, backups done with QAT have seen up to a 6% reduction in backup file sizes in the built-in compression. This means that over time, you'll use less storage space to maintain your backups, and your backups will take a lot less time. So you might be, So you might be wondering, how do I get Intel QAT? So Intel QAT is provided by the QuickAssist adapters, 8960 and 8970. It's also integrated into specific versions of the C620 chipsets. In the future, Intel QAT will be integrated inside the next generations of Intel Xeon scalable processors and will become even more readily available. Intel QAT is also provided as a software library, providing software acceleration by installing the QAT driver. So we're talking about hardware acceleration. Why would I mention a software version of QAT? I think it's important to note that, when we're using QAT integration with SQL Server, your backups are stored in a file format readable by QAT. If you back on a system with hardware compression to get that speed up, and you need to restore to a system that doesn't have the hardware option available, you can always use Intel QAT in a software as fallback. So you always have access to your data. You just won't get the benefits of hardware acceleration. So with the demands of today's SQL Server environments, Intel QAT will help you maintain your SQL environments with more efficient backups. And then back to Dave.
All right. So you can enable the hardware offloading on the server by performing an alter server configuration as shown here, and setting offload to on, which is disabled in the same way. You can use the same method to turn it off. And then a server restart is required for this setting to be enabled. And then after a successful restart, you should then run the select server property command to verify that QAT assemblies have been fully loaded and are available for SQL Server 2022 to use. The output of this function will either be a 1 or a 0. 1, it's enabled successfully, and 0 means it's not available. So if the feature is not available, then you would check SQL Server and Windows error log to address the issue and confirm that the device drivers and the QAT software libraries are available. Now, once you have verified that the QAT feature is available to use, you can either run manually or schedule your backups. In order to back up a database with QAT compression, is to simply run a regular backup statement and then append the statement with a compression and state QAT deflate for the compression algorithm. Now, if you were to just run this without doing the previous steps, would surface an error, and if this statement was run without QAT being available. Now, you can still run in the previous compression algorithm. To use the traditional backup method, all you need to do is say backup database, just as we did before, and say either with compression, having the algorithm equal to MS Express, or just by simply saying compression with compression without having this here, because that's the default anyway. So you still can do the QIT compression, you can do the standard compression. Actually, it'd be a good compare and contrast method using that. Okay, so Darren, what does the performance look like between these scenarios?
Yeah, so this slide it is meant to show how QIT performs. So I'd like to review some tests that we did in our labs and results showing the performance improvements that we have seen. The graph on the left is a normalized graph showing the speed up of backups on a bare metal system while the system is actively processing OLTP workloads. The orange bar is the baseline performing a backup using standard compression in SQL Server. And this is the time that we base the comparisons on. The green bar shows the performance while using QuickAssist with acceleration and software. As you can see, using the software acceleration, it's about a 1.4 times speed up with the SQL backup. But where we really get, the best performance is on where the blue bar there. The blue bar shows when QuickAssist is using hardware acceleration on an 8970 QuickAssist adapter. In this case, we see the best performance gain. The speed up configuration is 2.3 times faster than doing a SQL backup with the default compression. So this kind of shows the kind of improvements that you can see with hardware compression acceleration. And then on the right is a similar comparison when doing backups on a SQL server running inside of a VM while the system is actively processing OLTP workloads. Again, the orange bar is the baseline, and the blue bar is showing the speed up of the backup with the QuickAssist acceleration on the same 8970 adapter. When SQL servers run into VM this configuration, the speed up back is about 1.7 times faster than doing the backup with the default SQL compression.
Very good. All right, thank you, Darren. So this is kind of wrapping up where this is going to be like a really quick touch on some of the capabilities in SQL 2022 where we can drive better performance and scalability. There are a number of features in SQL Server 2022 that can take advantage of larger memory and more processing power. So all the encryption, parallel processing, and compression technologies are going to be able to take advantage of improved processing power. Features such as always encrypted enhancements, encrypted connections are all going to work better with stronger processing. And additionally, for like scalability features, think technologies such as the buffer pool parallel scan, system page latch concurrency enhancements, in-memory OLTP, and XML compression are all going to be able to take advantage of modern processing and higher core count machines. And so by improving and upgrading your parallel processing, this is going to drive us towards quicker results, better scalability, and overall better performance. I have another session today. I'll be covering many of these features, most of these features, in the SQL Server 2022 storage engine capability session later today. I hope to see y'all there. We'll have plenty of time for our Q&A coming up with the panel. But this is one of those slides that take a picture of. There's a lot of great stuff here, including the Microsoft Mechanics video, the SQL Server 2022 blog. We have demos, intelligent query processing demos, notebooks, which are fantastic walkthroughs for many of the stuff that we've seen in the training and what we've seen this week and the stuff that Bob Ward has put together. You go to SQL workshops, and the data exposed stuff that they do is fantastic. It's really good. One more thing here. Please see the early adopter program link on the slide. This is to gain access to a limited private preview intended for customers who can work directly with engineering, and that's how that process works. Again, you've seen this, but it really is feedback is really important. We've enjoyed having you, so please give your feedback. I hope you've enjoyed this session. I hope to see y'all again later today. We have quite a bit going on. We have the Ask the Experts, Ask Me Anything. We have that DBA deep dive Q&A. A lot of my colleagues are on with that. And of course, my last session, the SQL Server 2022 Storage Engine Capabilities session later today. To reach out to Darren and myself, please do, and ask us any questions. And so now I guess we can bring in other moderators and kind of just have answer any of the questions that we have. Darren, any last thoughts, final thoughts you would want to share?
Again, thanks for joining and hearing what we have to say about these new features for Intel and SQL Server 2022, Microsoft.
Go back to, let's learn more slide just in case. All right, thank you everyone.